morning, and let's start the new video and where we have ended up. Now earlier we have ended up to the discussion that we have to plot xt graph and vt graph xt graph, vt graph, at graph, xv graph, av graph, and ax graph. So these are the graph we supposed to draw, and the transformation will be also going to do, and in what manner we supposed to do you will surely see today. Now the another thing is very important, that once we are talking about let's take this is a mean position. So with respect to mean position, we have taken example of pendulum. Pendulum is supposed to be oscillating. Let's take these are the two position, extreme position, and once the pendulum start from mean position towards the extreme position and extreme to the mean position, and once again a reverse journey take place. Accordingly, we can say that at the extreme position, let's take the particle or pendulum having journey any journal x, because x has a maximum value at x at the x is equal to a. So intermediate, let's say particle is oscillating and x is equal to a is mean position, and let's say it is moving from mean position to the some extreme position. Fine. So let's take this picture in consideration, and once again I'm going to start with the equation of simple harmonic motion. F is equal to minus kx, and ma is equal to minus kx. So a is equal to minus k upon m into x, where we have assumed as omega square. So ultimately it will turn as a is equal to minus omega square x. Fine. Now let's take a, we can express as dv over v dv over dx, and it is equal to minus omega square x. Take variable separable v dv should be equal to minus omega square x dx. And once we integrate, now integration limit is important for getting the expression. Here we can say this is in terms of v and x. V and x, so this equation we can establish between v and x. Now limit should be, let's take this is a position, the particle is starting from the given position and velocity is heading towards the extreme position. So here, as we know already, that once the particle reach the extreme position, velocity will be 0. We have already summed up in previous video. So here, once we have taken the limit v x at x, the velocity is v, and let's say as a, velocity will be 0. So once we do the integration, so integration it will be v square by 2, that is equal to minus omega square x square by 2, and it will be v square by 2 is equal to omega square a square minus x square divided by 2, or we can say v is equal to omega under root a square minus x square. So this is the equation we can say between v and x. Now as we put the value of x is equal to a, so v is turned out to be 0. V is turned out to be 0 means this is x is equal to a is extreme position. At extreme position velocity is 0. So this is one of the relation, and let me quickly tell you about its geometry, its geometrical shape. So you can easily come across that v is equal to omega under root a square minus x square. By keeping whole square on both sides, v square is equal to omega square a square minus x square, or we can say v square upon omega square omega square plus x square is equal to a square. Clear? Or in another word we can say let's say this is the equation, and this is the equation, like either the variable v versus x. So it look like the equation of either circle or ellipse. Since the coefficient of x square and coefficient of v square, it is not equal. Hence we can say this is not a circle but it is an equation of ellipse. So the graph that we can plot between x, so this is the shape of it. So we can say the shape will be ellipse. So this is the derivation of equation number 1. Now let's sum up quickly what we have seen here. We have derived the relation between v and x, and how we have proceeded that you have seen already. Always remember one thing: while taking a journey between these two extreme positions, we have taken some general x where the velocity is v, and we have derived the relation general equation of v versus x. The x keep on changing. Here you have seen once we put x equal to a, the velocity turn out to be 0. So this is very important equation, and we have seen the graph of it. Graph it look like ellipse. So kindly remember this is a very important expression, and out of 6 I thought we have derived 1. Now let's move to the next part of it. Now we can say now we have already derived v x nature ellipse. Fine. An equation was v is equal to omega under root a square minus x square. Let's say equation 1. Now what we have seen here, if we can express v as a function of t, v as a function of t, so we can put dx over dt is equal to omega under root a square minus x square. Take a variable separate once again. Omega dt. Now let me quickly tell you the situation where we have started with. Let's say this is a mean position an minus a, particle having journey at x, having velocity v. This is the situation. So once we integrate, let's take t is equal to 0, the particle having some x naught, and t is equal to t. Let's particle reach some general position x. Let's take x. So once we integrate this integration, so as you know, integration 1 upon a square minus x square under root is equal to sine inverse x upon a. So it would be sine inverse x upon a. If you integrate x naught to x, it should be equal to omega t, 0 to t. So once we integrate it, ultimately sine inverse x upon a minus sine inverse x naught upon a is equal to omega t. So we have to take this x out to take it sine omega t to the next hand side. So it will be sine x upon a should be equal to omega t plus sine inverse x naught sine inverse x naught divided by x naught divided by a. I take n t inverse, so it will be x upon a sine omega t plus sine inverse x naught divided by a, or x is equal to sine omega t plus impact a sine inverse x naught a. So we can call x is equal to a sine omega t plus, let's say this whole function is supposed to call a phi. Phi is called as phase. Or initial phase. Clear? Initial phase constant. So initial phase constant, and this as a whole is called as complete phase. So as you know that phase it will depend upon the initial condition, and here we can say the initial phase can attain by infinite ways. Hence given equation is one of particular solution of f is equal to minus kx. Like this particular equation has infinite many solution, and this is one of the particular case or particular solution when we have defined the initial phase as this is the initial phase x naught by. So once the initial phase will change, my equation will also go on change. So always remember the initial position or initial phase will going to define my solution nature, and solution will change when the initial condition or initial phase will change. And the next important thing is A. As you can see, amount of energy it is given. Let's take the example of spring. if more energy given, so A will be also high. If less energy given, so A will be less. So what we have seen, that A is also depend upon energy given. A is depend upon energy given, and phi, it is depend upon initial position or initial state, or we can say initial phase. So there are two parameter. A, it will depend upon the energy given, because accordingly the amplitude will going to change. So here we can say A is energy dependent and phi is position dependent. So with respect to it, we can use this equation: x is equal to a sine omega t plus phi, and here we can say this is the second equation. Earlier we have already derived x is equal to vt. Now this is x versus t. Now once we have very much understanding of time, we can locate the position of x. Now here you can say the pendulum position we can locate anywhere. Once we have either x if given, to we can locate time, and if time it is given, we can locate x. The earlier equation, it was once x it is known, we can calculate v, and v it is given, so we can calculate x. So I thought we have done these two equations, and let's quickly see the graph of it. Now here we can see x and t is very much relatable. So this is x versus t. Earlier we have seen v versus x, the ellipse, and x versus t, it will form simple sine curve through which we can locate any particle with respect to time. So we have completed the two equation and two solution of the given out of 6 set of relations. Remaining we will surely check and derive in the next video. Till then, keep doing your studies. Thank you.